Hello and welcome to today's flipped instructional session. We're going to cover 4.06, Changing Velocity Math. Just a reminder, be sure to take notes during this recording. You're also going to want to have some example problems in your notes to help you when you get to quizzes and tests. So when you hear the words velocity and speed, there are a lot of things that can be really confusing with these terms. So one thing I recommend is having the definitions of these words and their formulas in your notes to refer back to. So we've talked about speed and we've talked about velocity. We know that when you add in velocity, remember that you're looking at a direction being added in. So this example talks about a horse with the fastest average speed wins the race. So the horse may be a slow starter and then come up from behind to win. The horse may be a front runner to begin with and be in the lead position throughout the race, but because the horse begins and ends the race at the same point on the track, the horse's velocity at the end of the race is 0. So remember, when you're talking about something that begins and ends at the same point, like running in a circle for this example, then you're talking about the displacement, how much the object was displaced during its course. And if it has started and ended at the same place, the displacement would be 0. And so we know that when you calculate velocity, displacement is a factor in that. And so if displacement is 0, anything we multiply times 0 is going to be 0 for velocity. So we'll look at this in more detail. But again, you're going to have to make sure you know the difference between distance and displacement. So there is a student guide that you're welcome to look through, but this is not required. All right, so as we get into the lesson, we're looking at the horse race again. So average speed versus the average velocity. The horse begins and ends the race in front of the judging stand at the distance marker 0. The race ends after the horse crosses the start or the finish line for the second time. Once around the racetrack is a distance of 2.0 kilometers. So the data table shows all of this data gathered for the winning horse. Okay, so if we're looking at the distance, we can see related to the time that at the very beginning, obviously he hasn't gone anywhere yet. So everything is 0. And then as the race starts, he's obviously traveling distance and time is passing. So that's what you're seeing here. And then at the end, it's showing 1.5 kilometers is the distance gone, but when you're back to the starting point, the displacement there is 0. And that just means that started and ended at the same point. So you can still run a distance. We know you can run a mile on a track. So in this case, they ran 1.5 kilometers on the track. But when you're calculating that displacement, it's 0 because of start and end point. So if we look at it, the average speed is going to be the total distance divided by the total time. So what is the total distance here? The answer that we're looking for is the distance of the track is 2.0 kilometers. Twice around the track equals 4.0. So it doubles, right? Therefore, the total distance is 4.0 kilometers. Okay, so it talks about the horse has to go across twice, so 2 times around. And then what's the total time? We can see there at the end, total time, 3.35. So 3 minutes and 35 seconds. So what's the average speed? So we've got to take the total distance divided by total time, and that gives us this 1.19 kilometers per minute. That's how fast the horse was moving. We're looking at the average velocity, and that's going to be where we plug in displacement. And what is the horse's average velocity from the first time it reaches the 1.5 kilometer marker? And don't forget the direction. So if you look up here at the chart, the 1.05 is going to be the distance it travels before it starts coming back around to that 0 point at the finish line. So that's why it's asking for that 1.5 number. So that's the farthest out that the horse goes before starting back. So that's the number that we're going to use, and the time at that point is 1.10. So when you look at the answer here, it shows that the displacement is 1.5 kilometers towards the start or finish line. Remember direction. The change in time is 1.10 minutes, so you just divide those to get 1.36. All right, so now the last question here, what is the horse's average velocity the entire race? So remember, displacement is 0 because we are back at the finish line, which is the starting point. It's taken 3.35 minutes. 0 divided by 3.35 equals 0. So that average velocity is 0 there. Okay, and that is different from speed because there we're just looking at the total distance. So remember, speed and velocity are different. All right, so now we're going to look at this in the form of some graphs. And there are a few mathematical terms and formulas that have to do with changes in velocity and speed. So now we're going to take a look at those, and these are the things you're going to want to get in your notes. So what we're looking at here is a coordinate system, and there are a set of reference points. We have lines and or directions by which the position of any point can be described. We know the x and y axis are used to define the location in two planes. And in a three-dimensional coordinate system, there's a z-axis. So that's what we're looking at here. Three-dimensional, obviously you can see the green there, kind of makes it a 3D figure. So you can see the normal x and y, and then the z makes it 3D. So you can look at some more images here. A reference point, to reveal, it's a point at which the position of the other objects can be described. A reference point can be 0 in a coordinate system or an object. So that's something to know. It's a definition there. These are in a different order. So now we're looking at graphs representing motion. So here you've got your x and y axis. You're seeing displacement over time, and it's comparing these two things at the bottom. Okay, and you're seeing just distance over time. Here's the speed formula. You want to make sure you have that in your notes. Speed equals distance over time. This is the velocity formula. Remember, the triangle means delta, so it's a change in x divided by a change in t, which is time. So it's talking about a specific direction, so it's a change in position, which is x, or displacement, and that's divided by time. So you want that in your notes as well. Data tables, just remember, showing us what's happened over the course of what we were timing. Here's another graph showing you position versus time again for runners. So you have 3 different runners. We're looking at the time it took for them to run 50, looks like meters. Here are your formulas again. If you had to solve for something other than speed, it shows you how to manipulate that formula. So distance equals speed times time. And time, you can find time by dividing the distance over the speed. So you have to kind of think about that mathematically. So that's something good to have in your notes as well. Again, looking at velocity, how you can change that formula to find velocity. Here you can find the displacement on the second one, and here's the time equals the displacement divided by velocity. So that's a good formula set to have as well. All right, so we've covered all of those. We're ready to go on. All right, so here's an example. I would definitely put this in your notes. Jeremy has a football game on Thanksgiving Day and it's expected to be over by 1 p.m. He is due for dinner at his grandmother's by 3 p.m. So he knows he can be ready to leave his house by 2. Jeremy uses his map app to determine that his grandmother's house is 25 miles west if he travels from his neighborhood on Highway 18 and through the streets of his grandmother's development. He knows the neighborhood speeds are 25 miles per hour and highway speed is 65 miles per hour. From past travels, Jeremy knows that the time on the neighborhood roads represent about half of the trip. So he wants to know how long it's going to take to get to his grandmother's house. So we have a lot of information here. And this will walk you through each step of it. Since it's Thanksgiving Day, Jeremy wants to make sure he'll be on time. So let's see if we can figure out if he will be. What do I know? We know that the time the game is over, it's at 1. We know that dinner is at 3. We know that Jeremy can leave at 2 and that the amount of time travel available, he has 1 hour to get to his grandmother's from 2 to 3. So the distance we know, he has to go 25 miles west. So that's important to know. We know the route is going to be in the neighborhood and on Highway 18. So we know there are 2 different factors there that we've got to figure in with speed limits. He can go 25 miles per hour in the neighborhood and 65 miles per hour on the highway. So the formula we've got to figure out, time is distance divided by his average speed. So average speed is going to be where we're going to do most of our problem solving because we've got 2 different speeds there. So his average speed, half the trip is at a speed of 25 miles per hour and half is 65 miles per hour. So to find the average, you just add those up and divide by 2 to give you 45 mile an hour average speed. So that is where you plug in that number. So the delta distance, so it's change in distance, he's going 25 miles at 45 miles per hour. So to find out the time it takes to go 25 miles at 45 miles per hour is 0.56 minutes, which is almost 1 hour. So this means if Jeremy leaves his house at 2 p.m., he'll arrive at his grandmother's, oh, that's half an hour. Sorry, I read that wrong. 0.56 is just over half an hour. So he'll get there just a little after 2:30 for a 3 p.m. dinner. So yes, here, I read that wrong. 0.5 is half of an hour. So a little over the half hour mark with that 6 there. All right, so hopefully that makes that clear on how to solve. So this just talks through about doing exactly what we did in that problem, getting the information you need and figuring out the formula you have to use. So there are some different strategies for reading the word problems. So if you're looking at this graph, it says, what's the average velocity shown on the graph? Okay, you're looking at displacement over time. So the formula, you know that we're looking at displacement over time. We have to learn velocity. That's the formula we're using. And it's an average velocity equals the displacement divided by the elapsed time. So why are we using velocity and not speed? Speed is a change in distance over time. Velocity has direction and uses displacement. The graph is labeled displacement versus time, not distance over time. So we're able to see that that determines the formula we've got to use. Okay, so since it is a straight line, any 2 points will give you the correct answer, any of the 2 points you plot. So here you've got V equals 25 meters in 10 seconds, which equals 2.5 meters per second northeast. Or you can use V equals the displacement divided by time. You have 5 meters divided by 2 seconds. Even if you go down here and pick this plot, it's showing you still get the same answer, 2.5 meters per second northeast. Where does the direction come from? So you're like, how do you get the northeast? I don't understand that. So the displacement is increasing in the positive direction. So this means the velocity is positive. So on a graph, we know we're only seeing the upper right quadrant. And so these numbers are all positive. And if you were to put this on a map, never eat sour watermelon, if you can remember that, right? That's your directions. It's traveling up and over, that's northeast. And so when you check your work, it's always good to go back. Did we use the correct formula? Did we read the graph correctly? Did we add or subtract? Is our math correct? And does our answer make sense? All right, so now filling in missing data. Here's another puzzle. So let's look at Tyler's example. He has an ATV race, and then as Mrs. Hudson explains how to determine Tyler's place in the race. So as you listen to that, think about whether the information is complete or incomplete.
I competed in an ATV race on Saturday. There were several judges at the event, but not all of them recorded the same information. How do I know if I won the race? I was ATV number 3.
All right, so if Tyler is ATV number 3, and you may have not heard, I don't know if that played in the recording or not, he's number 3, and so we're trying to determine if he has won the race. So what else do we need? You can see that ATV number 1, we have its displacement and time. For ATV number 2, we only have the time, and over here, oh, we have this displacement, or the velocity, I'm sorry. We have this velocity. So it's giving us different things. And on Tyler's, we've got 68 kilometers per hour east. We don't have the time, so we need to figure out how we can solve it. Okay, so this puts it on a graph for us. All right, this shows now you're able to look and kind of fill in the puzzle pieces based on working through the formulas.
Since you are looking at velocity, displacement, and elapsed time, you can use one of the variations of the velocity formula to fill in all of the missing information. Since this is a race, the start point and the end point of the race were the same for all participants.
All right, so the start point and the end point were the same, and so you are able to fill in the different spots. So with that and the time that it's taken in the recording, that will be something you can work through there on your own. But we'll keep going in order to get through, and I'll just go through the answers so that you can see how you got there and check your work. So the velocity of ATV number 1, you've got to divide 25 by 0.34, which is the time. Okay, so what we were given, and that gives us a velocity of 73.5 kilometers east. And then at the end of the race, we can assume that all ATVs are going in the same direction, so they'll all be going east. ATV number 2, we're using a different version of the formula because we're given V and T, but we don't have X. So we take the 86.5 kilometers per hour divided by, I don't know if they put the 0.5 in here, so that might be incorrect, times 0.29. Okay, those are two things that we are given here. And that gives us 24.9, or you could just round it to 25 kilometers. Okay, so that's solving for this. And we'll do the same thing for ATV number 3. Tyler's time was 0.37, so we plug that in for Tyler right over here, and then it gives us the Tyler, it looks like he came in 3rd. So when you plug in his velocity and time. So Tyler did not win the race. All right, so these are some more examples showing how you can solve the puzzle using your knowledge of speed and velocity. It takes a bus driver 20 minutes to pick up students from 4 stops. So these are great to work through and just test yourself. And then if you don't get it right, when you click check, it gives you some helpful information. So if you're struggling, you may want to add those problems into your notes, but I definitely encourage you to go through and not skip those. They will help you on the quiz. And then finally, you want to avoid common errors. Sometimes a word problem seems to have all the information, but it really doesn't. So if you're reading a problem a second time with the formula in mind, that can help you recognize the issue. So remember that displacement can be a positive or a negative number. If someone hikes 0.5 kilometers east and then 1.5 kilometers west, the total displacement is a plus 0.05 and a minus 1.55. So you subtract those to get a minus there, 1.05. Or when you're working it through the problem, you're not going to multiply it as a negative number. You're just going to use 1.05. So the negative is just showing the direction. And then always read the question carefully. Did you notice that the question about the average velocity asks only about the active hiking time? Okay, so it gives you a lot of information. You didn't even need all of it. It's just asking you about the time. So did you deduct the 15-minute break and the 30-minute lunch? Always check your arithmetic. If you push the wrong button on the calculator, the answer's wrong. So you always want to double check that. All right, so we've reached the end. Some more practice problems here that you can do. Again, I just encourage you to put these in your notes, have some examples, and make sure you know definitions and formulas. So if you have questions on those, you're welcome to come see me in Help Lab.